Okay guys, we're going to go ahead and start on the train project today. The train project has 9 parts overall that we're going to be creating on Inventor, and then we will eventually 3D print all of those parts so that way you guys can create your own train to take home. So I need you guys to follow this video exactly the way that I have it, because it will, if you do not follow it exactly this way, you will fall into some problems later on. So this part is, or this train is in inches, so we're going to go ahead and start a standard IPT. So go ahead and select that. And let's go ahead and get started. We're going to start on the XY plane, and all I'm going to put is a regular rectangle and a circle. Okay, this is representing the front of the train here that you guys have there. We're going to add some dimensions. Its overall dimension from left to right is 2 inches. This here, this height here is 0.88. And this, diameter is 0.75. It's the radius, so we're going to multiply that times 2, and we're going to get the diameter of 1.5. We're going to locate the center of this to its vertical location is going to be 1.38. Okay, and then we're going to use our constraints to line everything up. I'm going to use my coincident constraint to click on this midpoint of that line and the origin of the overall drawing, and then I'm going to use my vertical constraint to lock this in with my origin, and everything is safely put in the right location. And I'm going to say okay. Or not. Why? And I'm going to finish my sketch and extrude this. We are extruding this by, we're not going to extrude its full distance, which is 5.5. We're only going to extrude it to this surface, which is 5.5 minus 1.75. So I'm going to type that in, 5.5 minus 1.75. And that gives us this. Say OK, and I'm going to rotate it to the back, so I am looking at the back side. I'm going to select this surface and hit S on my keyboard for new sketch. Okay. All I'm going to do is make a rectangle using using what I already have, my geometry that I've already created. Going to use my coincident constraint to hit this corner and this corner. That locks that into place, and I'm going to say OK. And then I'm going to make an arc from here to here that has a radius of 2.3. Oops, I'm sorry. Let's try that again. A radius or an arc from here to here that has a radius of 2.35. Okay, that locks that into place, and all I'm going to do from this point is I'm going to dimension this the center point of my arc to here, and this is going to be 0.375, and I want to make sure, I'm going to use my horizontal constraint, I want to make sure that the end point here lines up with the end point over here, and that is fully constrained. I am going to trim away this top part of the rectangle, and that is that, and I'm going to go ahead and extrude. We're going to extrude this by 1.75, and there you go. Okay. So we have a general train look. I am going to go ahead and create a sketch on this face. Going to click that face, hit S on my keyboard. It rotates it, and I'm going to create a a slot center to center. So I'm going to put it here. I'm going to create the window for the driver, if this had a driver. And this this radius is going to be 0.5, and this midpoint, or this center point of this arc, is 0.25 away from the back side, so I'm going to put that there, and then it is 1.75 from the bottom, and that is fully constrained. Next, I'm going to put in some holes for where the wheel should go, and these 2 holes are going to be equal, so I'm going to select my equals constraint. I'm going to click here and here, and then I'm going to go ahead and locate them. This is 0.5 away from the bottom, and I'm going to do the same thing over here. Normally I would use a horizontal constraint, but I'm already on a roll. So this back hole is 1 away from the back, so I'm going to hit that. And then from the back to that center of this front hole is 4.5. And that properly locates that. I feel like I'm missing, diameters. I am missing diameters. So if I click on this, the diameter of this is 0.25. This is a threaded hole, so we will be threading it later. Everything is fully constrained. Let's go ahead and finish the sketch, and then we are going to extrude. We're going to cut everything out, and we're going the full distance all the way through, which is 2 inches, and say OK. Alright, almost done. I'm going to click on this front face. I'm going to hit S on my keyboard, and that creates a new sketch. And I'm going to place 3 holes. They're all going to be different random sizes, so I'm going to use my equals constraint to make them all the same size. Okay, I'm going to use my horizontal constraint, and I'm going to lock this and this center together. And then I'm going to also use my vertical constraint to lock that into to be vertically above or vertically in line with the origin. All right, let's go ahead and give these guys a diameter. The diameter of these holes is 0.125, and it makes them itty bitty, which is fine. And let's see, what are we seeing? What do we need next? Our vertical and horizontal locations of these holes. So our vertical location is going to be 0.125. And the horizontal location of this hole on the left is going to be 0.375. And the horizontal location for the hole on the right is going to be 1.625. Okay, so that's perfect. Next, we're going to go ahead and do a vertical location for that center hole, and that is going to be 0.625 from the bottom. All right, that's done. Let's go ahead and finish the sketch, and we're going to extrude these holes by 0.125. And it goes in. Make sure that you're cutting in the proper direction. Say OK. All right. We have 2 more holes to put in. We're going to put this hole on the top and then the hole in the back. Okay. So we're going to we can't create a sketch on this curved surface, so we are going to have to create a plane. So I'm going to click on the pull down menu on plane, and I'm going to select tangent to surface, parallel to plane. So it's going to be tangent to this surface and parallel with this plane, so that way if we look at it from the right, it's barely touching the top of it. So I'm going to click on that plane, and I am going to create a sketch. Make sure that we are looking at it from the top. And I'm going to put a circle in. This circle here is going to be 0.5, and it is 0.88 from the front. And 0.88. And then we're going to use our vertical constraints, I believe, to lock that in. Yes, and say finish sketch. All right. Let's go ahead and extrude. We're going to be extruding this. We're cutting it, so make sure that we're going in the right direction, and type in 0.25. We're not cutting all the way through, only a little bit. And there you go. So let's go ahead and click here, and we're going to turn off the visibility of this sketch, or of this plane, and that goes away. I'm rotating it to the back, and I'm going to put a sketch here, and all I'm doing is putting a hole for where this little button will go. Okay, it does share the same center point as that arc, so I'm going to click on project geometry, and that center point pops up. And I'm going to click here and put in a hole that is 0.25 in diameter, and we are extruding that by 0.375. I'm sorry, not 0.375, 0.5. We could have done this with the hole function. I completely forgot about doing that. We are cutting it out, and that is that. Okay, everything is perfect, everything is magical, but there are some things that I want to do before we move on. Since we are going to be 3D printing these parts, I want to create some things that we need to do before it can be 3D printed. So let's click on fillet, and we're going to fillet each and every one of these holes, because it makes things a lot easier to insert when there is a hole or a fillet to kind of guide it. If we had a flat 90-degree corner, it would be a little bit harder to do, or I'm sorry, a sharp 90-degree corner, not flat. It'd be a lot harder. So I'm going to change the radius of this to 0.05. Okay, and that makes it a little bit nicer, and I'm going to put that radius there as well. And say OK. So this part is completely done. Let's go ahead and save this. We are going to be saving it into our folder. We are going to be creating a new folder. This is going to be 6.1 train. Okay. And this is going to be the body. Cool. Let's move on. Let's go ahead and create a brand new part, a standard IPT, and we're just going to move down the line. All 4 of these are going to be revolutions, so we're going to start a sketch, and we're going to put on the XY plane, and we're just going to be making some rectangles. So a rectangle here. I lied, we're not making rectangles, we're going to use some lines. Okay. So one rectangle, going to go out at an angle, in at an angle, over flat, down straight, over across, flat, down, and then all the way down till it touches that rectangle that we started out with. Okay, let's add some dimensions. So this height here is going to be 0.25. Everything should move with it, and if it doesn't, I am sorry, Inventor is dumb. From this endpoint there to the bottom, this is going to be 1.5. Okay, moves things around. If something happens like it happens here with me, just cancel what you're doing and move your lines around, or undo and go back and try and fix it a different way. Its overall height is 1.75 from the bottom. And then this hole here, this guy, is going to be 0.375. And then from here to, why is that line crooked? If your line is crooked, use the horizontal or the vertical constraint to make it straight. And then we're going to trim that out. Okay, so you should have an open profile like this, no closed rectangular profile in there. And we're going to dimension from here to here. Hopefully it's not locked into place. Almost. And it is going to be 1.5 all the way down to the bottom. Okay. Let's go ahead and put in some diameters. This inner hole, or this hole, not hole, this diameter is going to be 0.25. Not diameter, radius is 0.25. If this happens, don't freak out. It's not a big deal. From here to the center, this is going to be 0.375 divided by 2. This guy here is going to be 0.875 divided by 2. And then the last piece of information that we do know is that point there to the center is 1.25. Right? Nope, divided by 2, sorry. Okay. If it does this, don't freak out, just grab that and move it in. Okay. What it does tell you is that it's at a 15-degree angle, so all I'm going to do is I'm going to draw a straight line vertically, or just like that, And I'm going to dimension from this line to this line, and it'll give us an angle, and that will be 15. Okay, everything is locked and fully dimensioned. It does say that I'm missing one dimension, but all it's going to tell me is that it's the length of this line. So let's go ahead and revolve this. It automatically selects the profile. So now all we have to do is select the axis. Okay, that's that. And that's that. So let's go ahead and save this part as stack. Let's move on to the hitch magnet. Easy. 2 circles, 1 extrusion, done. So 2 circles. One that is 0.25 and another that is 0.45. Extrude this, and this is going to be extruded by 0.25. And save this as Hitch Magnet. Moving on to part number 4, the hitch peg. Easy peasy. Let's go ahead and create a sketch on the XY plane. I am going to be revolving this, so I am going to draw a line horizontally flat out this way, and I will dimension it later. I'm going to go up, over, back, over, and end that there. I'm then going to put in an arc from the origin to this corner, and I don't know exactly how I'm going to have it, so I'm not going to put any dimensions. Let's go ahead and dimension this now. This is going to be 0.55 in total. Okay, total length from left to right, and this right here is going to be 0.5. Okay, it does, I'm sorry, it's not 0.55, it's 0.65. So change that. Alright, so here's what we need to do before we can move on. Okay, I need to draw a line straight up from the origin, so that way I can make this arc tangent with this line, and that locks that into place. And then it says that the radius of this is, it says SR 208. So SR means spherical radius, so this does have a spherical head or a rounded head. So 0.206. Okay, and then this is going to be diameter 40. Okay, why did it do that? That's fine. We'll accept that. And then this here, the body, is going to be 0.25 divided by 2. And this part is done. So let's go ahead and revolve it around its own axis. Say OK. And we're going to save this as Hitch Peg. Let's go ahead and do the linkage peg. I could say for you guys to do it on your own, but I'm on a roll. I'm feeling generous today. So let's go ahead and create, very similar to what we just did. I'm going to just go straight down from somewhere above the origin, and I'm just going to draw this general profile and then put an arc in. Okay, going to use my tangent constraint so that way I know that it's tangent here. Everything looks good. Let's go ahead and dimension it. Its overall length from left to right is 0.325. This body here is going to be 0.25. The diameter of the body is 0.125 divided by 2, and it'll give us a radius. And then we have an SR diameter, or a spherical radius, which is 0.562, sorry. And there you go. Let's go ahead and revolve this around itself. Very similar to that hitch peg, but this is called a linkage peg, so let's save this. This is one part that we will not be printing out, but it is necessary for the assembly file. Okay, we're not printing them out because they're super tiny when they do get printed out. So that's that. There are a few more parts. I'm going to end this video right here. We've been working for about 20 minutes, so go ahead and take a break, then come back and finish video 2.